Equations and tables. The relationship between independent and dependent variables can be represented with a table. We have the independent variable, or also known as the input in the table, and we have our dependent variable, also known as the output in the table. The independent variable is always in the left column, and the dependent variable is always in the right column. And the relationship between the independent and dependent variables, or the input and output, works like a machine. So here is a good visual for that rule machine. The value of the output relies on number 1, the value of the input, and number 2, the rule. The rule is the relationship between the input and the output. It says what happens to the input inside the machine, right? You start out with the input going inside the machine. The rule churns it up and does something to that input. And then out comes the output. It spits out the other side of the machine. The value of the output always depends on the value of the input and then the rule. So if you want to explore more with these rules and the idea of it's a machine, you can play around with this website. It gives you a bunch of different functions and rules that if you give it different inputs, you get to pick the value. It will spit out an output, and you can guess and try to play around with what is that rule, what's happening to the input to get the output. You also can practice with this as well. This is a different website that will give you a good idea of practicing and playing around with the rules. You can type in different inputs, and then you can guess the rule by typing certain operations, adding. The rule can be any type of operation you want with any numbers inside. It's just how are you manipulating the input. And then you can use the table feature to look at the outputs and again guess the rules. But we want to look at what if I give you the rule, or what if I give you input and output values, and you can see if you can guess that rule in the more traditional tables. So here we have a table, and we have the value of n is the input, and given the value of n, we want to find the output using the given rule. So where do we start? We usually start with the input. So again, we're told the input is the value of n. So we have a value of 20, 40, and 100. So we're going to find the output by using the rule of 2n. So that says we're multiplying the input by 2. So to find the output for 20, we would have to do 2 times 20. The output for 40 is 2 times 40. The output for 100 is 2 times 100. To get those values, each time we're multiplying the n, the input, by 2. So that would give us outputs of 40, 80, and 200. Again, with an input of n, we have an output of 2n, and we can complete the table. Let's practice some more here. Now we have a scenario going with the table and the input and output and rule values. So the manager of the department store raised the price $15 on each video game. Can you find an expression or rule that will satisfy the total cost of the video game if given the original price? So here we're using the table values. We have to fill in the table values first based on the scenario, and then try to come up with a rule of how the input and output is related. Well, we're told the manager of the department store raised the price $15 on each video game. So that means we're going to need to add $15 to each video game. We'll have to do $100, the original price plus $15. We'll have to do $55 plus $15. We'll have to do $38 plus $15. We'll have to keep adding $15 each time. So that will give us an original price of $100. It would then be $115. An original price of $55 would go to $70. An original price of $38 would go up to $53. Each time, like we saw before, you're taking the original price and you're adding the 15 because it's being raised that high. So the rule, the expression we can give is that if you have an input of X, you would do x plus 15 to find that price after markup to find the output. An input of x and an output of x plus 15. That would be our rule. Here's another example. We have a parent wants to figure out the differences in grade level of her two sons. The younger son is 2 years behind the older one in terms of grade level. So let's try to use that information to write an expression or rule containing a variable which satisfies the difference in grade level of the two boys. So we have an input of the older son's grade level. So we've got when he was in grade level 6, 10, and 2. So 6th grade, 10th grade, and 2nd grade. And then we're trying to see in general, so we're using G for any grade. So we have the scenario is that the younger son is 2 years behind the older one. So 2 years behind means 2 years less. So we have to subtract 2. We would want to do 6 minus 2, 10 minus 2, 2 minus 2 to get that output value. So that will give us, if the older son is grade level 6, the younger would be grade level 4. Grade level of 10 would go to 8. 2 would go to a grade level of 0 or kindergarten. So if we are now in general have an input of the variable G, the rule is that we're taking that grade level of G and we're subtracting 2. You would have the rule of G minus 2 to relate the input and the output in the table. Tables can also be used to represent equations. So here we have the table below represents the equation y equals x plus 3. The output of y depends on the input of x. So you can see each time the rule is adding 3. So we go from 3 plus 3 is 6. 4 plus 3 is 7. 6 plus 3 is 9. So x is the independent variable on the left, and y is the dependent variable on the right, and we have the rule between them is x plus 3. So we can use that fact to find missing values in a table. So this table is representing the equation t equals n plus 11. So to find the values of t, we need to use that equation as our rule. T, the output, is going to be the input plus 11. So if the input is 10, we would have to do 10 plus 11 to find t. If the input is 28, we have to do 28 plus 11 to find t. And if the input is 40, we have to do 40 plus 11 to find the output of t. So if the input is 10, we're going to have an output of 21. 28 plus 11 is 39. 40 plus 11 is 51. So this table is representing the equation t equals n plus 11. Here's a different example. We have y equals x minus 60. So the input of x, the rule is we're subtracting 60. So if we have an input now of 80, the output would be 80 minus 60. An input of 120, the output would be 120 minus 60. An input of 180, the output would be 180 minus 60. So an input of 80 minus 60 is 20. 120 minus 60 is 60. 180 minus 60 is 120. So this table is representing the equation y equals x minus 60. Let's do another one. We have now the table representing the equation t equals n divided by 5. So we want to find the values of t for the given values of n. We're using the rule n divided by 5 with these given input values of n. So to find t, we would first have an input of 20. We would do 20 divided by 5. For an input of 40, we would have 40 divided by 5. For an input of 80, we would have 80 divided by 5 to find those outputs. So 20 divided by 5 is 4. 40 divided by 5 is 8. 80 divided by 5 is 16. This table is now representing the equation t equals n divided by 5. Here's another one. We have y equals 2x. That is the equation, the table. We want the table to represent that equation. That's the rule for the table. So again, we have our input values of x. So we're going to use 2x as our rule to find the output of y. So to find when an input is 20, we'll have to do 2 times 20. When the input is 40, we'll have to do 2 times 40. When the input is 100, we'll have to do 2 times 100 for that output of y. So 2 times 20 is 40. 2 times 40 is 80. 2 times 100 is 200. This table is now representing the equation y equals 2x with those values for the input and the output. We can even do this for a real-life example. So equations and tables can be representing that real-life information mathematically. It's more visual to see it in a table. It's a good way to organize all of the information you're given. So here our example is that Natalie is going ice skating. The skating rink charges $6.25 per hour of skating. So we will let H represent the number of hours of skating. So that is going to be the independent variable. That would be our input. And then C is going to represent the total cost. That is our dependent variable, our output. So if we think of the equation for $6.25 per hour of skating, that gives us an equation of C equals 6.25H. So if we have our input of 1, we multiply by 6.25 to get 6.25. An input of 2 would be multiplied by 6.25. 2 times 6.25 is 12.5, so $12.50. And then again, an input we have here of 3, so we would multiply 6.25 times 3 to get 18.75. So we can see in the table, using the equation, we can see how many hours of skating and what would be the total cost. So here is one last example of another real life situation. So we have Mary's age is twice the age of Jack. So now we're giving you Jack's age and we want to kind of complete the table and think of an algebraic equation which can determine Mary's age M given Jack's age J. So we would say that if Mary's age is twice the age of Jack, you can think twice is multiplying by 2. You would do 12 Jack's age times 2. You would do his age of 14 times 2. His age of 24 times 2 to get Mary's age. So 2 times 12 is 24. 14 times 2 is 28. 24 times 2 is 48. If we're taking Jack's age and multiplying it by 2, we would get Mary's age is equal to 2J. So we can use the table to see the rule between the input and the output. In fact, anytime you have a table, you have your input and your output, and you have a rule in between them, and often that rule is written as an equation. So you can use that equation once you know the rule to then make new table values or new data points in your table.